So today we're going to be talking about properties of numbers, and there are 4 basic properties that we're going to be looking at. There's one more that you're going to learn this year, but we're going to talk about it much later. So just 4 today. So if you open it, the first property is called the commutative property. All right, and basically the commutative property means you can add or multiply numbers in any order. All right, so when you have 2 numbers to add together, like 2 plus 3, it doesn't matter if the 2 is first or the 3 is first. 2 plus 3 is 5, and so is 3 plus 2. Same thing when you multiply. If I do 2 times 3, that's 6. If I do 3 times 2, that's also 6. All right, it's the commutative property that allows us to add or multiply in any order. All right, so some of what you're going to have to do is you'll be given a set of numbers or letters, and you'll have to say what property is being used. And so the way we remember commutative property, okay, is this 10 over here, commute. Like you may have talked or heard your parents talk about their commute to work. That's when you move from one place to another, right? So if you if you start at home, right, and you have to go to, let's say this is a bus, or this is your commute to school. That's a bus, yes it is. Okay, so you commute to school. Here's the school. All right, so the commute is how you get there, right? You go from home to school, and then your commute home is you just turn around and go the other way. All right, so nothing really changes except which direction you're going. That's what a commute is. All right, so the commutative property is just talking about adding or subtracting, and you can do it in any order. You can go from home to school, or you can do school to home. All right, so sometimes it's more helpful to see it in numbers. So we kind of already talked about this, but if I have 2 plus 3, that's the same thing. It doesn't matter if I change the order to 3 plus 2. My answer doesn't change. 2 plus 3 is 5. 3 plus 2 is 5. They're the same. Doesn't matter what order. Same thing with multiplication. If I do, let's just change it up, 4 times 5. If I switch the order and make that 5 times 4, right? 4 times 5 is 20. 5 times 4 is 20. Okay, they're both the same. Switching the order didn't change them, and so that made it, that means that commutative property works for that. Now, you're going to see that the commutative property doesn't work for subtraction and division, right? So you want to pay attention to that too. It's only when you add or multiply. So, for example, 2 minus 3 would be -1, but 3 minus 2 would be +1. Okay, for division, if I do 4 divided by 5, that's a fraction, 4/5. If I do 5 divided by 4, that's like 1 1/4. So they're not the same thing. So these properties are only going to work for adding and multiplying. All right, the second property we're going to look at is the associative property. And you may have heard of the word associate before. So when you associate with a group of people, those are the people you interact with. Those are like the people you hang out with. It's your group. You associate with them. So the associative property also has to do with grouping. All right, so in this property, it's telling us that the order hasn't changed. Okay, A plus B plus C and A plus B plus C. Right, it's all adding. These are all in the same order, A, B, C, A, B, C. But it doesn't matter which 2 numbers I add first. I can add the A and the B first, or I can add the B and the C first. Same thing with multiplication. If I have to multiply all 3 numbers together, A, B, C, I can choose. I can multiply the first 2 numbers together, or I can multiply the second 2 numbers together. These properties are helpful if you know them, because sometimes it's easier to add the last 2 before you add the first one. The associative property says that's okay. All right, so when you add or multiply, you can group numbers in any combination. All right, so let's see what that looks like with actual numbers. So let's say I have 2 plus 3 plus 4, and I want to compare that. 2 plus 3 plus 4. All right, so the associative property says I can either start by adding the 2 and the 3, or I can start by adding the 3 and the 4. And the associative property says it won't matter what order I add these in, they'll be the same. So 2 plus 3 is 5, plus 4 is 9. Over here, if I do the 3 plus 4 first, I get 2 plus 7, which is also 9. So did it work? Yes, it does. Okay, so again, if I have a group list of numbers and they're all being added, I can add them in any order I want to. Same thing with multiplication. If I have, let's say, 5 times 2 times 3, and 5 times 2 times 3. Notice my order is exactly the same. Order's changed up here with commutative property, right? But not here with associative. So I can multiply the 5 and the 2 first, or I can multiply the 2 and the 3 first. 5 times 2 is 10, times 3 would be 30. Over here, if I start with the 2 times 3, 5 times 6 is also 30. So again, the associative property is going to work for adding and multiplying, but not subtracting and dividing. All right, look at the identity property. So when you hear the word identity or identical, if you think about identical twins, what makes them identical twins? They look alike. So think of when you keep your identity, you stay the same. Or when you have an identical twin, you have someone that looks at least as much like you as they can. Okay, you don't change, you're the same. So the identity property is talking about what you add or multiply by that keeps the number the same. So the sum, that means when you add, right, of what in any number is the number. So what can I add to any number and get the same number? 0. Okay, we're just calling that, you already knew that, but we're just calling it the identity property. So anything plus 0 stays the same. Okay, what about with multiplication? What number can you multiply times any number and get the same number? Well, 1, right? So if I multiply, or the product, just means multiply, of 1 times any number is going to give you the exact same number. Again, that's something you already knew, but we're now just describing that as the identity property. All right, so let's look at an example. If I have 2, and I want to keep it a 2, what's the only number I can add a 2 that will make it stay a 2? 0. 2 plus 0 is 2, right? Same thing with multiplying, but it's a different number, right? What times 3 is going to give me 3? 1. Okay, that's the only number that works. So 0 and 1 are the identity properties for adding and for adding and multiplying. Now, you can't reverse these though, right? If I do 2 plus 1, does that work? Nope. And I can't do 3 times 0. Does that work? No, that gives me something different. All right, last property is the inverse property. So your hint for this one is when you use the inverse, what you're doing is sort of undoing the number. It's what you're starting with something and you're kind of taking it apart. All right, so for positive and negative numbers, right? If I have a number and then I add the opposite to it, what happens? It just becomes 0. So I start with something. If I add the opposite, I get rid of it. I've undone it, is how I think about it. So the sum, when you add, of a number and its opposite is 0. This is the inverse property. All right, so what gets rid of the number in multiplication, or what changes the number in multiplication? Well, the product, you're multiplying, of a number and its, we call it the reciprocal, okay, is always going to be 1. All right, so I can start with b, but if I multiply it times 1 over b, okay, so I can make this b over 1. If I multiply times 1 over b, then what I end up with is b over b, which is just 1 whole. All right, so we've taken b and we've undone it. That's how I remember the inverse property. All right, so look at an example, a numeric example. So let's say we start with the number 4. Okay, well, what plus 4 is going to give us 0? What does a 4? Well, negative 4, right? The opposite. 4 plus negative 4 equals 0. That's your inverse property. All right, with a fraction, you might have 2, and it says times its reciprocal is always going to be 1. So if I do 2, what's the reciprocal of 2? Well, reciprocal is when you flip that fraction upside down, so I have to make 2 into a fraction and then flip it, 1 over 2. So that becomes 2 over 2, which is 1 whole. All right, so taking a number and multiplying by its reciprocal gave us 1. That's all the inverse property is telling us. Right? Or it doesn't always have to be a whole number. You could start with a fraction like 3/4, Okay, if I want to make 3/4 into 1, I multiply it by its reciprocal. So the reciprocal of this would be 4/3. 3 times 4 is 12, 4 times 3 is 12, which again is 1 whole. All right, so the inverse property is telling us a number plus its opposite is 0, or a number times its reciprocal is 1. All right, so the problems you're going to be asked look like these on the front here. All right, so again, one more reminder, these properties work only for addition and multiplication. They do not work for subtraction and division. Just kind of keep that in your head. So you're going to have to, given these problems here, identify the property that's shown. So you're either going to say it's the commutative, associative, identity, inverse, or none. Sometimes they're not going to show you the correct property, and so that's a case you would say none for. All right, so here I have a number plus -3 is equal to 0. So what is this? This is a number plus its opposite equals 0. So which one of these was talking about undoing the number, right? Inverse right here. But this is the inverse property. And if you forget, just go back and look at your notes. That's okay. And this is the inverse property for addition. And I'm just going to put like an addition sign out to the side because that's going to help me remember that it works. Because if I think it's inverse, but I put a subtraction sign, then I know it can't be right. All right, so look at 4 plus 5 and then 5 plus 4. All right, so here they start it with a 4 and they add it 5. Here they start it with a 5 and they add it 4. So all they've done basically is just reverse the order, right? They went from 4 to 5 and now they have 5 and 4. So which one of these talks about order? Well, commutative, right? Because your commute, okay, is where you go to school and you come home, or you go to home and then you go to school. So commutative is the name of this property. Okay, and this is adding as well. Okay, for C, I have 2, 3, 4, and 2, 3, 4. All right, since these numbers are in exactly the same order, 2, 3, 4, 2, 3, 4. I know it's not commutative. All right, I'm not doing any opposites, so it can't be inverse. Identity is when you just multiply or add something in it. You get the same number, so it's not identity. Looks like it should be associative. Okay, what did associative have to do with? It's who you hang out with. It's who you're grouped with. So did the grouping change on here? Well, yes, it did. So here I had grouped 3 and 4, but over here 2 and 3 are grouped. So all that changed was the grouping. So this is associative, and this is for multiplication. All right, here I have 5, 2, 1, 5, 2, 1. So the order is not different. Did the grouping change? Well, yes, it did. I have 5 and 2 here, and I have 2 and 1 here. So this looks like associative, but what's wrong? Associative doesn't work for what? Subtraction, right? So this is one of those times where it's a little tricky. These aren't equal to each other. 5 minus 2 is 3, minus 1 is 2. Over here, 5 minus, what's 2 minus 1? 1. 5 minus 1 is 4. Is 3 equal to 4? Nope. That's because the grouping, because the associative property doesn't work when you're subtracting. None, and that's because it's subtraction. All right, 5 times 1 equals 5, so I'm multiplying times something, and it stays the same. All right, which one of these talks about staying the same? Your identical twin, right? Identity. And which is being used, adding or multiplying? Multiplying. All right, here, 3 over 4 and 4 over 3, and I get 1. All right, so what happened? These kind of canceled each other out. All right, so this is an inverse property. And it's for what? It's for multiplication, because I'm multiplying times the reciprocal. All right, for G, I have 8, and then 2, and then 2, and then 8. Okay, so what changed here was the order. So that sounds like commutative. Commute is when you go to school, and then from school you go home. Home to school, school to home. Okay, it's what it looks like. But does commutative work for division? No, so this is none. And why is that? Because it's division. 8 divided by 2 is 4. 2 divided by 8, not 4. Okay, it's 1/4. The last one, H, you have 0.6 plus 0.2 plus 0.1. Okay, on the other side, you have the 6, the 2, and the 1. So the order exactly the same. What changed was the parentheses. They were grouped differently in this one. So this looks grouping like it should be associative. So I just want to double check. Does associative work for addition? Yes, it does. So I'm okay. Associative, and it's addition. All right. So again, these can be a little confusing at first. Just keep referring back to your notes if you need to, and then try to remember the hints. That's how we remember what the different properties stand for. So commutative is about order. Okay. Remember your commute back and forth. Okay, associative is about who you group with, who you hang out with. Identity is about staying the same, keeping the same identical number. And then inverse is kind of when you undo the number somehow. And then none is what you're going to get if you're, if you're dividing or subtracting. All right, thanks.